All right, so here's your quick review on molar mass. So you've done this quite a bit, but I just want to go over a couple of things that students commonly miss. So when you have a covalent compound like this, students, you don't tend to make too many mistakes. Biggest things are you'll notice that we kept that 0.00, even though when you enter it in the calculator is going to give you 96. But you need to remember that we're trying to show how accurately we know these numbers, so you need to keep those 2 decimal places. So you have 2 decimal places on your answer. The other thing is the unit. All right, so remember what you're doing is you're trying to figure out how many grams for every 1 mole. So your unit on this is going to be grams per mole. All right, then another example. Wait, can I not? Hold on. Okay, there we go. Okay, ionic compounds a little bit more challenging in that you need to distribute this 2. So you need to recognize that this means, okay, I have 1 mg in here, and then I have 2 oxygens and 2 hydrogens. Sorry, that times 2. All right, so another one, let's say it was Na, nope, Al, NO3, 3. All right, so I want you to quiz yourself on how many Als, how many Ns, and then how many Os. And then, all right, so Als, get your answer. Should be 1 Al. Ns, get your answer. 3 Ns. O's, get your answer. 9 O's. Because remember, what this is this is Al, and then we've got an NO3, an NO3, and another NO3. All right, so I see 3 N's, and then I've got 9 oxygens there. So make sure when you're distributing that you are looking at the subscript. If it's inside the parentheses, only applies to that atom. If it's outside the parentheses, it applies to the polyatomic ion. All right, and again, you add things up, and again, make sure, especially with those oxygens, keep the 2 decimal places. Respect the 0. Zeros are important, and then it needs to be grams per mole. All right, hope that helps.